Hey guys, I know it's been a while, but I've recently moved. I've been doing stuff. I'm back on YouTube though. I have a really cool project that I want to talk to you guys through soon. But today we're doing another coding problem. This question is currently being asked by Google, Amazon, and Facebook. Let's get to it. Hey guys, so this question is currently being asked by Google, Amazon, and Facebook, and the question is decode string. The problem description is given an encoded string, return its decoded string. The encoding rule is that k of an encoded string, where the encoded string inside the square brackets is being repeated k times. Note that k is guaranteed to be a positive integer. You may assume that the input is always valid, no white spaces or square brackets, and square brackets will always be well formed. Furthermore, you may assume that the original data does not contain any digits, and that digits are only for those repeated numbers k. For example, there won't be input like 3a or 2 bracket 4. Cool. So for this first example, this example 3 bracket a and 2 bracket bc will end up being a bc bc, because the a will be enumerated 3 times and the bc bc will be enumerated twice. And then in this second example, we see this being nested. So we'll see the content inside this 3 being enumerated 3 times. And then again, we'll see that this like A, the 2 CC will be enumerated. So we'll get ACC, ACC, ACC. Cool, so I think this makes sense. So the approach that I'll go with then will be like just how I talked through it. I'll go from the outside and then move in. And then like a way we could do this is we're always going to be looking for 2 main things. We'll need to solve problem 1, find number, and then problem 2 to find, and then because I'm going 1 level at a time, find first level of info inside bracket. And as we solve these problems, we'll be recursing. I guess because we're moving to a termination condition, we can be recursing. So we'll say like we'll keep going until we don't see when we see no brackets in S, return. So to find the number, we could use regular expressions. So we could like import re, and we could use re.match, and the syntax would be like a digit to our value. And we can say like if this exists, then we want to keep walking through and find the end of the number, because numbers can be from 1 to 300. So we want to do that. And then we want to do something actually pretty similar with finding the first level of info inside the bracket. So find left side of bracket, then walk to end. And we could do this with something like a stack, but the way that I'm thinking of it, doing it is similar to the balance parenthesis problem. We could have some balance value, and then we can minus equal 1 for an open parenthesis and plus equals 1 for a closed parenthesis. So the time and space, if we did this, if we keep recursing at each level of nested brackets, would be O of n times k, where k is the number of nested levels of brackets. So if there's like 7 nested levels, we're gonna find the first level 7 times, walk through it all 7 times, so it'd be 7n. And then our space, we haven't really talked through that, but that would be k times on the call stack plus every time we're creating a new string. We could call that new s and pass that back in. And that would be like n new space. So we want to first get our termination condition. So if open bracket not in S and close bracket not in S, we can return S. Otherwise, we want to create all these things we were talking about. We want to import re first, and then we want to have this balance value. And then in order to set our number, we want to have a current num. I'll initialize that to -1, and we want to have like our left digit index, our like left index for the beginning of the bracket, and I'm going to set those to -1 as well. And then I think we're good to go. So now we want to just iterate over our list. And so we're going to say for I in range len s, if first we want to find the number. So problem 1, identify digits. So we can use the syntax if re.match and our balance is equal to 0, because we only care about finding the number inside our like the non-nested level. Then we can say our left digit is equal to I. Oh, but then actually once we're in here, we want to say like if our left digit isn't already set. So we want to say if our left digit isn't already set, then we want to say our left digit is I. Else, so we could also just say like if left digit is not equal to -1. So if it has been set and we're not at the end of our string, so like len s minus 1 is greater than our current value of I, we can like step one forward. So we could say like if re.match, and we don't want to look at value, we want to look at s at I. So now we can step one forward, we can say s of I plus 1. Then we can say continue because we want to keep going. Else we want to set our current num, and we're going to set that equal to the integer of s from our left digit to our index plus 1, because index aren't inclusive. And then we want to say our left digit is initialized back to -1. So when we're not solving this problem, we're going to be solving problem 2. And this is going to be finding the info inside one level of brackets. And the way we can do this is we can say like elif s at I equals our open bracket, and balance is still 0. We want to say our balance minus equals 1, and our left index is the next index because our current index is a bracket. And then we can just say elif our balance isn't 0, and we see a bracket. We want to change our balance. Elif s at I is a closed bracket. Now we want to add one because we want to get back to this 0 condition. So once we have a 0 condition and our left is set, we know we've seen like a right. So we can say like if balance equals 0 and left is not equal to -1, our new string, which we haven't created, but I mentioned up here, we're going to be like passing in like k more times because we're going to be recursing on this, equals this. Our new string can be plus equal to our current num times the s from our left value to our right I, which is like currently a closing bracket. Then we can set our left back equal to -1, and we can set our current num back equal to -1. So there's something I'm missing here that I just realized, and that's that there's a case right here with like ABC3. We want to add these ABCs at the beginning. So like if we have like an elif our s, or like now like I guess we want the case that there's no brackets. So if our current num is not set, so like we're right here, ABC is not set. So if it equals -1, our new s plus equals s at I. So then once we solve this and get to the end of our for loop, we want to say our self.decode string. We want to return this function of our new s, and we want to keep recursing until we get to this termination condition. So our goal is that we want to find, like on the first level, we'd want to find, for this example, 3 as our current num and a2 bracket c, and then we want to pass that in as this a2c, a2 bracket c, a2 bracket c, a2 bracket c, and then do that again and get to acc, acc, acc. So let's see if it does that. Cool, and that looks like it works. And let's run this on everything. Awesome, so that worked. So if you guys have any questions about this, just feel free to put them down below. Yeah, this is actually a pretty tricky problem, and with a lot of string problems, you'll see that like you'll need a lot of cases. So just to cover these two sub-problems, problem 1, identify digits, and problem 2, we need like a ton of elif statements. So just always make sure when you're doing string problems and recursion problems, one, you have that termination condition, and then two, you're covering all the possible cases with these open and closed parentheses, with like this lack of balance with finding your numbers. But yeah, I hope that was helpful. Hopefully I'll see you guys again soon. Have a good one. Peace.